Hello, my geometry students. We are doing lesson 213 on supplements and complements, which is really kind of like a nice little shortcut way to sometimes get around subtraction postulate, stuff like that. So first things first, we're going to start with the supplements part of it. If we have the given diagrams here and here, and they tell us that angle ABD is congruent to EFH. So let's mark that. ABD congruent to EFH. And ABD is supplementary to DBC, so the one next to it. And then EFH is supplementary to HFG, the one next to it. Then what we can say is that the supplementary angles are congruent. So we can say that angle DBC is congruent to angle, so this guy over here, we'll put two stripes, HFG. And the reason that we're going to be allowed to say is that the supplements of congruent angles are congruent. Now it sounds a little funky, so I'm going to say it this way. I'm going to say congruent angles implies congruent supplements. So there's our first new reason that we're allowed to use in our proof. So if I know these are supplementary, and you can know that from the diagram, and I know one pair of angles is congruent, I know the supplementary pair is congruent. All right, same rationale, so it'll make it really quick and easy to talk about. This one, instead of having supplementary angles, you can tell that we're going to be looking at complementary angles. So the rule in this case is going to be if we have congruent angles, then we can get congruent complements. Now you can say congruent complementary angles if you prefer, but congruent complements is fine. All right. So, and I'll put that in parentheses. So you could say congruent complementary angles would be your other option. All right. So with this, they're telling you ABD, this guy is congruent to EFH. And then these ones are complementary, those are complementary. And therefore, we could finish out by saying that angle DBC is congruent to angle HFG. Now, the only difference in a diagram, these are more like vertical angles where you can look at it and see. Like I can see this is a straight line, so I know that it's a linear pair, it's supplementary. Here, I cannot assume that they're just going to be complementary. So you need to make sure that you know that you have right angles first, or maybe perpendicular first. So I would have to know that this is a big right angle before I can just hop into saying that, like, oh, congruent angles gives me congruent complements. But you'll see that when we get into the proof. All right, flip it right on over. We are on page 43 here. All right, the first one. We got a bunch of different givens. Some of those givens just clarify the diagram. So let's just get them down. So we've got a straight line ACFG, straight line BCDE. So just clarifications there. All right, here's some useful stuff. ADE is congruent to angle BFG. So let's mark it. ADE, that angle is congruent to BFG, that angle. Right? And that is all given. Now, if you want, you could put the last given in there with it as well. I know I've been letting you do that, so sure, what the heck, we'll throw it in there. DC is congruent to FC, and while we're at it, let's mark that. DC is this, FC is this. Okay, if you look at what we're trying to prove, in the end, we want to prove that angle DAC is congruent to angle FBC. Okay. If I'm going to prove a pair of angles in the end, then I really should have a little goal step here of getting the triangles congruent first, then we can get the angles. So the nice thing is, let's just use those same letters and let's get triangle DAC congruent to triangle FBC. And then if I can get those triangles, then bam, we can go right on to getting those angles. So it's beautifully set up. Okay, with that in mind, DC being congruent to DC being congruent to CF, that's a pair of segments in those triangles. So there we go. Nice. All right, this pair of angles, though, is not inside the triangles we want. Here's where our new step comes in. So I can use this angle here to get the angle next to it, or its supplement. So let's do that. This is angle ADC, or you could, of course, call it angle 1. And this is BFC, or you could call it angle 2. I'll be particular today. Let's go with angle ADC is going to be congruent to angle BFC. And then our reason over here is to say that congruent angles implies congruent supplements. Woohoo, there's our new step. That does give me a pair of angles inside the triangles. So now I've got a side, I've got an angle, and I'm out of givens. But we know to look at the diagram. And if I'm trying to get these two triangles congruent, right here, I'm going 3 stripes. We got some vertical angles. Let's make it easy. Let's call that angle 1 and call that angle 2. Why the heck not? So we can say that angle 1 is congruent to angle 2 because vertical angles implies that we're going to get congruent angles. All right. Now when I go back and look, this is where we get to kind of focus on just one triangle at a time. So if I come back up here and I focus on just this triangle right here and I ignore everything else, I've got 2 angles and the side in between. So that's a little angle side angle right there. All right, so step 4, that's our goal step. We want to prove that triangle DAC is congruent to triangle FBC by a little angle side angle. Lovely. So that we can now finish that proof and say that angle DAC is congruent to angle FBC. And that would be by the corresponding parts of congruent triangles are congruence. All right, done. Please be super, super cautious with your notation. Triangle versus angle, whole different ball game. So really important to be very, very neat and particular about what you're doing. Also make sure if I see ASA here, that's because I had 2 angles and a side back here. All right. We have one more proof to do together, and then you'll have some time to work. So for this one, we've got that BF is the perpendicular bisector of AC. That's really 2 givens in one right here, but we're going to write it down regardless. And then because that's 2 givens in one, I'm actually going to make you split up some of those givens for once, because I just feel like it's kind of too much stuff to look at, right? We got plenty of space, though. We'll get it all in there. So let's start with BF is the perpendicular bisector of AC given. All right. Now, before I get too far ahead of myself, let's look at where we're going with all this. We know we got a perpendicular line. It's going to bisect. And eventually, we're working towards AD, that segment being congruent to CE. Like you've learned, the only way we're going to get there is to prove some triangles congruent first, and then we can steal those parts. So the triangle that AD is in would be triangle ADB, and then congruent to triangle CEB. All right, so that's really what we're working towards here. All right, let's see what we can do with this. So we've got, let's focus on the perpendicular part first. Perpendicular lines is going to give us right angles. And in my picture, BF is perpendicular to AC. That's going to give me a big old right angle here and a big old right angle here. I am not going to call those angles 1 and 2. Please use the letters here. So angle ABF and angle CBF are right angles. All right. Take a look at the next given. The next given they actually give us up here, if I slide up a touch, was angle FBD. So FBD this, and angle FBE that. That's part of those right angles. You can see where we're going to go with this. So I know I could have put it in step 1, but oh well. FBD is congruent to FBE because it's given. And now you can kind of see why this could be a subtraction postulate, but this is actually a little simpler because we've got right angles and we have part of the right angles. We can jump to saying that the other piece of the right angles has to be congruent, or the complements are going to be congruent. So that's going to leave me with this little guy right here and that little guy right there. So let's say that angle ABD is now congruent to angle CBF, or excuse me, CBE. And then our reasoning over here is that congruent angles implies congruent complements, or congruent complementary angles, however you prefer to say it. Cool. All right. Those little angles that we just proved, those are in the triangles that we want. Put an A next to it. All right. Now, if we keep going, let's see. We actually didn't fully finish that first given. Remember we said that's two parts? If I look at it, we did the perpendicular. We haven't done the bisector part of it. So if BF bisects AC, that means that we have a segment bisector, which gives us, sorry if I'm a little crooked here, two congruent segments. All right, let's look in that picture closer. It's bisecting AC, two congruent segments. That's going to give me AB and BC over here, right here, AB and BC. So AB congruent to BC. And those are segments in our triangles. Nice. So we got a pair of angles, we got a pair of sides. We are looking pretty good. I would say we're out of givens, but we're not. We split them up, remember? So come back up here. We fully used this one because there was two givens in one. We use this one. Here's the last given we haven't touched yet. BDA, angle BDA. So BDA, this guy. Maybe I'll go 3 stripers. And angle BEC, this guy. If you don't want to do 3 stripes, you guys, you could always put like a tick mark on the stripe. That's another way to show that they're the same. You could get some colors out. Go crazy. All right, so angle BDA is congruent to angle BEC because they told me, woohoo, given. All right, that is the last pair of angles inside the triangles that we want. So step 7, I've got enough to prove our goal step, that triangle ADB is congruent to triangle CEB. Now I have 2 angles and a side to work with, but use the diagram to be diligent about this. I'm going to slide back up. If I focus on one of those triangles, so this guy right here, and I block out everything else, I have 2 angles and the side is over here, not in between. This is angle, angle, side right there. All right. So AAS is going to be my reason for step 7. And then finally, if I know the triangles are congruent, now all the parts that, correspond are congruent. So I can say that segment, sorry if you can hear my dog, Teddy, he's having a moment, AD is congruent to CE, which really just means there's someone like walking by and he's really pumped. And that would be by corresponding parts of congruent triangles are congruent. All right, that's it. Awesome job. Thanks for sticking with me. Go give that homework a try.